Hey guys, I'm up to section 8.2, objective number 5. Remember in YouTube, if you hit that gear wheel, you can speed me up to like 1.5 and I think you'll be fine. So in objective 5, what we're about to do is use technology to compute and interpret a confidence interval to estimate the difference between two means in the situation again of independent samples and the population standard deviations unknown and unequal. So in general, confidence intervals' purpose is to estimate. If we're comparing two means, like the mean score of girls with a mean score of boys, we'd like to be able to estimate the difference in those two scores with an interval. As in chapter 6, we're going to follow the format of a point estimate plus or minus a margin of error. Okay, point estimate plus or minus margin of error. If we were back in chapter 6, 2 chapters ago, you would have seen x bar for the point estimate plus or minus e. And then e had an equation in chapter 6. The e equation in chapter 6 was a t critical value multiplied by a standard deviation over the square root of the sample size. Okay, so now here in chapter 8, our point estimate is now going to be x bar 1 minus x bar 2. The e equation is changing to this, and then to form the interval, we're going to go take that point estimate minus the margin of error and that point estimate plus the margin of error. And that's a fair amount of work to do out by hand, so I'm going to let you guys rely on technology for this. So with technology in the stat tests menu, option 0, so that would be 10 lines down on that screen, you choose the 2 sample t interval. It's going to want the summary stats for each sample, the confidence level, and you're going to leave that pooled option on the default no. Once again, the degrees of freedom are found with a complicated formula, and it's going to get a more accurate interval, and you're not responsible for the formula. So the most important thing you're responsible for is after computing the interval, there's 3 scenarios. Once we get that range of plausible values out of the calculator, its job, remember, is to estimate the difference between the two population means. And one of 3 things are going to happen. Either both endpoints are going to be positive, both are going to be negative, or you'll end up with one negative and one positive. So in the positive endpoint scenario, you're going to be, say, 95% confident that the mean of population 1 is blank to blank greater than the mean of population 2. If both endpoints end up negative, will only make sense then to say you're 95% confident that the mean of population 1 is blank to blank less than the mean of population 2. But in the scenario of 1 negative and 1 positive, that means with confidence you can say that the mean of population 1 is anywhere between blank less and blank more, okay? Less than and greater than the mean of population 2. If we relate this to significance testing, getting a negative and a positive endpoint is going to have an interval that would include 0. So it would basically be plausible that the difference between two means were 0. So in this minus plus case, you will see that the hypothesis test would be in a two-sided case, a fail to reject HO decision. In either of these cases, a plus plus or minus minus, you would get a reject HO decision. Okay, so here's the one model problem. We're going to do the example at the bottom of the page. So notice that I'm just expecting you to calculate the interval and most importantly interpret in context. Okay, so the stem of the question talks about comparing the mean lifespans of African elephants that are in the wild and in a zoo. So in order to do that, you randomly select several lifespans from both locations. The results are shown in this table. So once again, the problem's kind enough to put the summary stats right there in front of us. So in order to construct the confidence interval, your job would be to go put those summary stats into the stat test option 0 and then output your confidence interval from the calculator. So I'm really just asking for 2 steps. When I did this in my calculator, It showed the left endpoint at 34.57. And remember that I'm estimating a difference between two population means. Okay, and then it showed the right endpoint at 43.63. Now number 2 is what I consider the more important thing. What if we just learned about comparison of wild and zoo elephants? We can make a statement that reads, we are 95% confident that the mean lifespan of wild elephants Okay, so the mean lifespan of wild elephants is between 34.57 and 43.63 years greater than the mean lifespan of zoo elephants. So as you can imagine, that's important information to somebody. Okay, maybe an activist who wants to show people how much longer animals live in the wild than they do in a zoo. So the job of that confidence interval is to estimate just how much longer that is based on the data obtained in this investigation. All right, that's it. That's the end of section 8.2. Hope that helped.